Okay, so just how acidic is a solution? Well, it's important to be able to monitor just how acidic something is for a lot of different chemical reactions. Some things won't even happen unless the solution's acidic. So it's nice to be able to stick a little probe in and it tells you the acidity. Well, we're going to have this pH scale that can actually quantitate just how acidic something is. And to give some meaning to this, like if the pH is below around 4.5 or lower, it's so acidic that little fishies die. To make something like beer, they want the pH at, I forget what it is, right? There's different ways that they want everything going here. Oh, their yeast and stuff dies on them. Inside your own body, they're not even sure how it works, but if things keep getting really acidic, somehow you go from stuff dying inside you to getting abnormalities and cancer. They're not so well understood. They're still researching that. But neutral solutions. What pH do they have, Caroline? 7. See, I think you already know a lot of this kind of stuff. The acidic solutions. pH, Jasmine, what was that? Acidic solution. Was that pH really low or pH really high? Low, so it's going to be less than 7. And then everybody basic would be pH bigger than 7. Okay. Self-ionization of water. Ionization is little tiny charged particles, right? And they know, AJ, that there's always an equilibrium going on between water and its ions. The water's actually falling apart and decomposing. It decomposes into what and what? Kind of, yeah. The acid is H+, the base is OH-. Yeah. The equilibrium constant, Brandy, big K, would be what over what? Brackets, yeah, for concentration of H+ and OH negative. Anything on the bottom? No, she caught it, right? Why is it just that, or over 1? Because it's a liquid. She saw it. Okay. For these equilibrium constants that are kind of important and you can Google them and find out what they are, they usually have subscripts. Water is no different. If you write its ionization reaction that way, that's its equilibrium constant, Kw. And you can Google it. It'd be a number, and it's actually 1 times 10 to the negative 14 is the concentration of hydrogen ion times the concentration of hydroxide in just natural pure water there. Albert, does that look like a really big number? No, in fact, it's really, really small. It's a decimal point with 13 zeros and then a 1. So pure water isn't very acidic at all. There's hardly any H+ or OH- in it. But it happens to a small degree, and there's this equilibrium going on. So, helpful hints to predict pH of strong acid and base solutions. And I changed this a little bit because I'm always changing stuff, so that's just how it is. Anyway, helpful hints to predict pH of strong acid and base solutions. Know the formulas of the 6 strong acids. Victoria, we're going to be doing all these calculations to, what's the pH of this solution? What's the hydrogen ion concentration? What's the hydroxide concentration? We're going to be playing these games, and we're going to use these equations to get it there. But life is so much easier if what we're working with is a strong acid or a strong base. And that's all we're going to be working with today, but the next class period not. So we really need to know what those formulas are for the strong acids. Do you remember? You got half of them from the periodic table. Which 3 do you get? Which half? You get 3. I get 3 strong acids by looking at the periodic table. HBr, HCl, and HI. It's not HF, right? 2 polar. Okay. There's 3 more that we should really be familiar with, Cassandra. What are the other 3? No. HNO3 H2SO4 and HClO4. Okay, now the reason why these are a big deal is because these are all super strong, right? They're strong. They dissociate what percent? 100%. In fact, we're going to see this. The reason why is because if you have 0.01 molar HCl, well, if it dissociates 100%, that means that you're going to have 0.01 molar H plus. Because it dissociates 100%. So whatever the concentration is of that strong acid, that's the concentration of the H plus. Because it all gets converted to it. And that's the reason why we have to know what the strong acids are. Because this only works for strong acids or strong bases. Well, that means we should know what the strong bases are. We use some of them in lab. Does anybody know? The other, NaOH, good. It's that OH stuff we're worried about. Really, all you got to do is follow the solubility rules. And we talked about last semester. It was a while ago. And we said I put any of these ions with any anion. It always dissolves it's soluble 100%. Do you remember which group it was? It's group 1. If I put those group 1 ions, lithium, sodium, potassium, with any anion, it always dissociates, dissolves 100%. Well, there's your strong bases. Just put lithium, sodium, and potassium, those group 1s, with OH. So then you're going to have the same story. If you have, I don't know, 0.89 molar LiOH, it's a strong base. So the concentration of my hydroxide would be 0.89. Because it's a strong base. That's why we need to know what the strong acids and strong bases are. So we can just immediately write down what the hydrogen ion or hydroxide concentration is. Solutions of strong acids and bases always dissociate 100%. That's the complicated way of pretty much just saying this. Right? That's what's important. Yeah, there's a few more, but the exceptions to solubility rules, I don't really. Calcium, strontium, and barium. I don't think you're even going to see them in the homework, so I wouldn't worry about it. Okay. A few more changes that I made to your notes here. Here's our pH equations. Now, I want to make sure that we can see them as equations. So, Mari, to do that, I'm saying that there's two ways to find the hydrogen ion concentration. We can use equation 1 or equation 4. We can use this one or this one. Okay. Which one do you want to solve for the concentration of hydroxide? 1 or 4? Which one looks easier? Oh, we're saying hydrogen ion. Hydrogen ion. Yeah, 1 or 4. 1 or 4 for hydrogen ion. 1 looks easier than 4? 1, that hydrogen ion concentration is inside the log. Right? I don't know. To me, that looks complicated. In 4, to solve the hydrogen ion concentration, you just do what to both sides? Can you see it? We want to solve for hydrogen ion. Yeah. In fact, just kind of disregard this part, because this is all we're really interested in, right? It's hydrogen ion times hydroxide is 1 times 10 to the negative 14. So if you want to solve for hydrogen ion, just divide both sides by OH concentration. So I think that's the easier one. Well, hydrogen ion is 1 times 10 to the negative 14 all over the hydroxide concentration. So they'd have to tell you what the hydroxide concentration is. You plug it in and you get hydrogen ion. Okay. But there's another way, and that's equation 1. With equation 1, if you want to get hydrogen ion concentration, they have to tell you what? pH. They have to tell you this number. Okay, that's the other way. Now, Mari said that was a lot easier. I don't think so. But, Eric, here's the equation. pH equals negative log of hydrogen ion concentration. Is everybody with me so far? You see how I rearranged 4? We're okay? Okay. So here's equation 1. And I'm picking on Eric, saying, okay, I'm going to give you a pH. Now I want you to solve for hydrogen ion concentration. How do you do it? We're close. We're getting there. So you have to raise both sides to some. Yeah, it's little e if it was a natural log, but it's log. So you raise both sides to 10. Okay, now let's just show you this. Let's bring so the 10 and the log cancel out. They're literally just gone, and you're just left with the hydrogen ion concentration. But for that to work, you got to get rid of that minus sign and bring it over here. So it's really 10 to the negative pH. So raise both sides to the 10 power. So 10 to the negative pH and 10 to the negative log hydrogen ion, but the 10 in the log part cancel out, right? So we'll get rid of the negative sign first. So 10 to the log H plus, 10 in the log cancel out, and you're just left with 10 to the negative pH is hydrogen ion. Okay? And how you take 10 to the negative 8.2 or whatever, we'll do that. We'll show that on our calculator. It's no big deal. We'll figure it out. So those are the two ways to get hydrogen ion concentration. Now, you can use equations 2 and 4, to get hydroxide, right? Again, with equation 4, just divide both sides by. So now we're trying to find hydroxide. So divide both sides by the H plus. Yeah, that would be one way. Okay. You'd have OH is 1 times 10 to the negative 14 over the H. Okay. How about using equation 2? How could you find it? Can you see? It'll be the exact same way. In fact, the answer is going to be what? 10 to the negative POH is equal to OH minus. Okay. But what I'm driving at here is a couple things. One is, this is all I'm giving you. Right? So you need to know how to manipulate those equations. And we'll have some practice on that. That's what we're going to do pretty much the rest of the hour. Okay. So we have those equations. Here's our question. Well, starting out, first one. If hydrogen ion concentration is 3.8 times 10 to the negative 3 molar, what's the pH? So I'm giving you hydrogen ion concentration. I want to know what pH is. So you got to look up in those equations and find one with pH in it. Summer, it looks like, what equation could you be using here? So you could be using the first one maybe, or maybe which one? Three has a pH in it, right? It just depends on what else they gave you. So I'm just saying, looking at this, they want pH. I know I'm going to be messing with one of those, but let's look more closely here. They say the hydrogen ion concentration is 3.8 times 10 to the negative 3 molar. So you're going to be using which one? Number 1, right? Because number 1 says pH, negative log, hydrogen ion. Okay, now how do you do this in the calculator? It's going to be the negative log of 3.8 times 10 to the negative 3. What you got to do is you got to put the 3.8 times 10 to the negative 3 in the calculator first. Then you push log, right? There's no memorizing. You have to do what the equation tells you. It says put this in the calculator first, you push log, then you take it times a negative 1, and you have your answer. Okay? So 3.8 times 10 to the negative 3, push log, and then take it times a negative 1. That's what it says. That's the last thing. 2.42. So make sure you can get that on your calculator. 2.42. All right, 3.8 times 10 to the negative 3. Push the log button, take it down to the negative 1. Did it work? Monica, did it work? Oh, you got to have a calculator on this stuff. Make sure you bring calculators to class, otherwise you're not getting the most out of your time here. Okay. pH is 2.85. What is H plus? pH is 2.85. What is H plus? Vanessa, see an equation we should use? They give us pH, and it wants to know what the H plus concentration is. They give us the pH. I have to use 2 equations.
Or we can do the first one. Number 1 again. Yeah.
The first one. You really don't have much choice because they give you pH. I mean, you can start going around and around, and it'll get the same answer. But it's going to be, if you use anything else other than number 1, you're going to have a job on your hands, right? Okay. They said pH is 2.85. If it helps, put in numbers. That might help you to see what to do next. This is the one where you got to get rid of the log. All right. So you got to raise both sides to the 10. It's that whole 10 to the negative pH is the hydrogen ion concentration problem, right? Because you got to get rid of the log. Yeah, bring them over. It's just that 10 to the negative pH is the hydrogen ion concentration one. Or you can actually, manipulate it every time. But you raise both sides to the 10 power. So you can either start here, if you want to remember it, or do what Summer was saying, right? Just take that guy and manipulate him. You'll have a negative 2.85 equals log hydrogen ion concentration. Raise both sides of the 10 power. 10 to a negative 2.85 equals hydrogen ion. Okay, now how do you do this? Do you see a button on your calculator that would work pretty good for this? Do you see it? 10 to the x. Exactly. What is your x? Your x is a negative 2.85. So put in a negative 2.85, the plus minus, right? And the 10 to the x is yellow, so shift 10 to the x. 1.4 times 10 to the negative 3 is my hydrogen ion. Right? Makes sense? You see it, Vanessa? Okay. Now you don't want to go through all this work and get knocked off a point for units. What are the units for concentration? Big M, molarity. So don't lose points for that. pH doesn't have units. Nope. Okay. Now it's starting to get ugly. This is about as ugly as it can get, actually. If pH is 8.35, what's hydroxide? All right, you can see our equations again. Okay, what's that? Summer, you got a plan? And she says number 3. Okay, so she says if she wants to use number 3, do you see the route she's going? She's going to use equation 3 to get what? Because you know what the pH is. You can solve and get POH. And then you can use this guy to get hydroxide. There's another way. If you don't like that way, you could do 1 to get hydrogen ion concentration, then use 4 to solve for hydroxide. There's 2 ways. So see if you can pick a way and try it. And then I'll show you one way or the other up here and see if our answers agree here. Sounds like a good number. Right? Okay, how I'm going to do it is how we described it first. But you keep going. See if you can get an answer. Summer got 2.2 times 10 to the negative 6. Oh, okay. That's what Caroline got. I bet you that's right. Okay. Yeah. Yeah, because all concentrations are in big M units, molarity. I got the same answer. So you can solve it this way, or you can use equations 1 and 4 instead. Okay. There's two ways to skin the cat. Everybody get it? Good. Okay. Try these then. Try these. Is A question that you'd really like to see on a quiz? Or is it going to be work? It's really easy. Why? Yeah, the answer is 0.25. Because HCl is a strong acid, there's nothing to do. Right? Right? Yeah, B too. Right? Now B would be a job. Oh, no, here it is. C is making it a job. Right? But see how he's a strong acid. So if I want to give an explanation here. It all breaks up completely. 100% dissociates. So it's going to be HCl doesn't exist. H plus and Cl minus do. So they each break up into 0.25 molar.
For the third one, would you have to use the equation? Because they give you the OH when you say your OH.
Okay, before we get to C, everyone agrees with the first two? Okay. Now, okay. There's an easy way and a hard way. Maria says use number 4. That would be how many steps? Well, really 1, because right, you know hydroxide is 0.15, and you put it in, so it's really 1 step, right? Just divide. Now there's another way though, that would be more work. What would it be? You can go through several, right? You know hydroxide is 0.15, so you just pick one. Maybe find POH, and then you just find pH, and then from pH find hydrogen ion concentration, right? So and you'll get the same answer, but right? Why? Why not use what's a lot easier? So go ahead and use equation 4. Because it's only 1 step. We know hydroxide is 0.15, so you just solve for hydrogen ion. sign of the who? Right? Isn't that Satan? Rotten 6.67. Okay. All right. So let's try working on D. What is a pH of 0.05 molar NaOH? If you're not sure where to start, just ask. Or ask your neighbor or something. On D? Okay, so you know this is 0.05. So you could, but then you get POH. Yeah. Yeah. That would work. Well, no. You put in that number for OH.
Okay.
Take the negative log of it, and you have POH.
Oh, okay.
That'd be one way. D.
I crossed it out because I thought I wrote it wrong, but I think I need to take this one.
Yeah, you could find H, then just take the negative log of it. That would work.
It's just like negative log.
Right?
Yeah, I guess I wouldn't have to raise
'Cause
anything to it.
no,
Right?
no, because it's pH.
Yeah.
You could do it that way too.
To do that, would I do to the negative 13 log and then hit negative?
Yes. It's looking good so far. So that is pH. Oh yeah, you're done. Right? Because you found POH, right? And then you, oh, it's 0.05 though. That should be a 0.
I put it in here.
Okay. So did anybody get an answer for D?
Yeah, I got 12.7.
12.7. Okay. You should be getting 12.7 for D. If you got 12.7 for D, go on and keep working here. But if you didn't get 12.7, let me help you out. Okay. Wonka, did you get 12.7? No? Okay. So 0.15 molar has to be the hydroxide, right? So what are all of our equations at? Okay. So you know the hydroxide is 0.15. So you know he's 0.15. So you could just take the negative log of them and find POH, then put it in over there. Did you get it? You can. You don't have to, but you can. Because you could use this one too. Because you know hydroxide in brackets. You know he's 0.05. So you could use this equation, or you could use this one. If you use the top one, I think it's easier. Because you just take the negative log of 0.05. No, it's just POH is a negative log of it. So you just put him in the calculator, 0.05, push log, negative sign, you have POH, then come down here, put that number in for this, solve for pH. Or use this one. Put the 0.05 in for OH. Solve for H plus. You divide both sides by 0.05. Then you know what H plus is. Then you can put them in up here. And right?
So, yes, and that's
H3O plus, yeah, so H3O is 1.2. So hydroxide, yeah. Yep. I don't know if the math is right, but that's how you do it.
okay.
Okay, it's just a trick question. H3O plus is H plus. So if you know, which one do you know by, if it's HBr, 1.2 molar, you know the concentration of H, or H3O plus, same thing, is 1.2. And then the concentration hydroxide, use, where's that one? The one with KW, this one. This one? Okay. So you put in this guy for, it's 0.05. Then you got that. And this is exactly what you do. That's exactly right. H3O plus is just the complicated way of saying H plus. They're the exact same thing. Okay. It's this one, right? 0.15 molar. This one says 0.05 molar. What is a pH of 0.05 molar NaOH? Sorry. I think you're doing it right. Right? You take the negative log of 0.05. Yep. Okay. So keep going. You got 12.7. Remember the trick for 53 if you've done it already. H3O plus is just the complicated way of saying what ion? H plus. They're the exact same thing. Okay, if it says 1.2 molar HBr, then you know the concentration of what? Of which one? H, because this is a strong acid. So H plus, or this thing, H3O plus, has to be 1.2 molar. So that one's done. And then to get the hydroxide, just use the KW one. Right? Because you know he's 1.2, solve for him. Yeah, they want to find H3O plus, which is that, and hydroxide. Yeah, they want you to find both. And to find the hydroxide, use the KW. It'd be the easiest way. If you're stuck on any of these, just ask. Remember, did you get an answer for this? 8.310. Okay, That's what I got too. How about this one? 77. What'd you get? What is it? Hydroxide's 0.427. Anybody else get that?
Yeah, you can do it that way. I'm gonna do 1 and 4.
Did anybody get an answer for 77? Ramiro got 0.43.
Yeah.
Oh, Maury got 0.43. You got 0.43?
Actually,
Okay.
4 from.
2 times 10 to the negative 3.
Yeah.
Monica, what did you get?
Point,
0.43. Oh, somebody messed up. How did you do it, Summer? The
They
pH?
use the pH. The 14 equals.
14 equals pH plus POH is how you started out?
Yeah, and POH equals 2.36.
Yeah, so she solved for POH, and then you did the 10 to the negative thing. Okay, let's try it that way.
4.2732. Is that what you got?
That's fine.
Maybe you guys didn't read your exponent there. Remember. So 2.37 for POH. Yeah. Ramiro, we should have a 10 to the negative 3 in there. 4.27 about. 4.3. Right. Did you see where you missed it? Did anybody wrap these up? Did you get an answer for 63? You'd answer what for 63? Oh, yeah, acidic A and C. Yeah. Yeah, neutral would be B and basic D as in dog. Obtain the pH. Okay. Obtain the pH. How'd you do 67? Did you get 67 done? You just take the negative log of it, exactly. And what'd you get, Eric? 2.12. Okay, good deal. Obtain the pH of the following hydroxide ion concentration. Now it's going to be 2 steps for sure, right? What's that? Okay. You got 8.2? Anybody else get 8.2? 8.3? What's up? This one?
No, well, this one. I can't.
Oh, okay. Jump up there. Let's show you it. So Ramiro, did you get 2.37 for POH? Or did you do it a different way? So you used.
And then
Oh, you raised it 10 to the negative. You got the concentration of H plus first. Is how you did it, huh? pH is negative. That should work. Yeah, that'll work. You just somewhere in your calculator you didn't read the little bit where it says, the little exponent there. You just wrote down the big number. Because you got the exact same thing, pretty much.
So this should be like this, right?
Yeah, so 10 to the negative 11.63 will be hydrogen ion concentration. Then you put that in, and then you divide both sides by this. This should be 4 times 10. This is 1 times 10 to the negative 14.
14? Oh.
That's where it is. That's 1 times 10 to the negative 14. All right, there's about a minute left. Did anybody get the last one knocked out? What did you get? 5.72? A lot of people are getting 5.72. Okay. So I'll be glad to help you with any of this stuff. Just come by.